our speakers that we heard this morning, part of the panel. And I would like to give just a brief introduction about Professor Tafazoli. He's a professor of electronic engineering, mobile and satellite communication, and director of Institute of Communication Systems, and director and founder of the 5G Innovation Center and 6G Innovation Center at the University of Surrey. So I feel we are in very good hands for managing the panel that is now following. Rahim, the floor is yours.
Thank you, Monique, and for introduction, and thanks to all the presenters, which is presented really exciting vision and activities from all over the world. And I have to say that I was this morning, it was 7 a.m. UK time, I was on a panel on Beyond 5G Japan International Conference. And that was exciting as well. There's lots of ideas and vision towards Beyond 5G and 6G, which I try in this session to share some of the things I learned on the panel and share it with you. By all means, there is a Q&A button at the bottom of your screen, and that you can ask any questions that you would like to ask the panel. To start with, let me start the question is, do you think it's a good timing to discuss 6G now? I think that's, by the way, can I ask all the presenters, put your video
can all
on.
Presenters switch on their video? Thank you.
Thanks very much.
Jana, great, thank you.
Okay, so everybody can see you, and we try to answer some of the questions. The easy one is now, do you think we should start discussing 6G? Is it a good time? I start with my right-hand side. I can see Takehiro-san's video. Do you want to start with that, Takehiro?
Yeah.
Why do you think it's a good time to start 6G discussion? Or
yeah, actually, that's a very good question. And yeah, I have already compared with the 5G history, and in the 5G research and development, the projects was established around the 2013 or 14 all over the world, and the white paper also published around that timing. But compared with the 5G and the 6G, 6G case, we are now establishing many projects. Even from the 2020 or now 2021. So it means that maybe around 3 years ahead. Yeah, actually. So very early timing, actually, compared with 5G. But around the competition, global competition is much harder, and also global needs, market needs is very higher and higher. So in that sense, we think that it is proper timing to start the discussion on 6G, I think. But from our market guides mentioned that it's too early because they are they need to make a big effort to make a good business for the 5G system for now. Yes, too early for them, but for the R&D, our technical guide's point of view, it is the timing to start the 6G, we think. Yeah.
Okay, thanks very much for that. I'm going to ask ITU, Uwe, why are you starting your 6G activity now?
No, well, this is...
What would you like to establish?
No, we didn't establish. Actually, ITU, you need to understand the working method of ITU. The working method of ITU, it's contribution driven. So as Nakamura-san said, we have received contributions from the ITU members to stimulate, to start the discussions, not only technology trends, which we are working already 1 year on, but now also to start the definition and gathering information from the external organization on the vision for IMT 2030. So when contribution driven, we are processing the work. And as you have seen in the time plan, I have shown you from the ITU perspective until we have at the very end the relevant recommendation for the systems beyond IMT 2020, not wanting to call them yet any other name. It will take some years, and also Nakamura-san said it was 2014 when we started, and the first publication of the 5G specifications has been in 2021. So we are talking about a time frame, not wanting to say 10 years, but let's say 7 to 8 years. We have now the leap to 2022 plus 7 and 8 years makes it 2030. So I think the timing by the members stimulating the work within ITU is proper timing. And depending on how many radio interface technology candidates we may receive, you may remember my presentation. For the 3G, so for IMT 2000, we had, I think at the very beginning, 12 candidates, and we ended up with 6. We had then for the, let's say, 4G, we had 2 because I think there were too many. Now we have 4 to 5 radio interface standards for the 5G systems, and we don't know how many we will get for the 6G systems. I personally hope a limited number of, but this consensus building and analysis evaluation will take time from the ITU process. Yeah, so I think it's the correct timing.
Yeah, good, thanks for it. Kai, is it Germany started the 6G program? National program. Is it international race? Or why? What is the reason behind Germany's 6G program?
Well, the reason for it is that, let's say, there were some effects from the corona epidemic, and let's say kind of a future, let's say, stimulus package that Germany wants to invest in future technologies, and 6G is seen as a candidate for a very important technology, also, let's say, providing solutions for society and industry, and therefore it's the right time. Also the opportunity that the funding is there, that is also very important, let's say, to have that at hand. Well, yeah, and I think yes, in the past, Germany just invested, let's say, in the applications of 5G, and I think it's a good time now at the beginning to, let's say, also have a close look at 6G, let's say, to put all the requirements of the industries there right at the definition of 6G. So I think it's the right time, and also, let's say, right now we are educating, let's say, the expert for the future when we are deploying the 6G network. So you have to start somewhere to educate these people, and now it's the best time to do so.
Okay, thanks. Can I just say that Bernard Barani from the European Commission, he had to leave, but he said that he may rejoin the panel discussion. So I would have asked him the same question about the European Commission. And we have Xiao Zhu is representing the IMT 2030 from China.
Yes.
Yeah, but I'll ask David Lister to start with. NGMN, you said that you're gonna, from next year, first quarter of next year, start coming up with the use cases for 6G. What do you think 6G should do that 5G is not capable of doing it?
Thanks, Rahim. And this is one of the questions which we will be reviewing as a group, because the use cases are, by definition, use cases, but that doesn't explain whether or not the more mature 5G networks would actually be able to support them. And I think Nakamura-san made a great point in his presentation, actually. Technologies aren't necessarily 5G or 6G per se. Technologies will be introduced as demand requires them. So many of the features that we might expect to see will emerge, I think, through the 5G evolution, 5G maturity timeframe. And then what becomes 6G is then to be discussed and to be analysed. And I think one of the things we need to consider as well is we have a very capable 5G framework and IMT 2020. In fact, it delivers, and it's specified to deliver data rates up to 20 gigabit per second and millisecond latencies and so forth. And the reasons why we don't get this today in wide area networks today is because there's limits, there's practical limits to do with spectrum and bandwidth and power and real world aspects. So those 6G use cases and requirements, they have to be borne in mind with those practical issues. And then we'll work through as a group within NGMN to try to understand what, if anything, cannot be supported with that 5G framework. Clearly, there's a lot of fantastic new technologies and proposals coming through. The joint sensing and communication sounds very interesting. And it's trying to work out where those particular new technologies provide that added value. So that's what we'll be doing going forwards.
Yeah, okay, thanks, David. I'm looking forward to see the work of the NGMN when it is ready next year. Zhu, China.
Yes, Professor.
Yeah. Why do you think it's the right time?
Yeah. Yeah, I think we all know that normally it usually takes 2 generations for the telecom network to make new services full-fledged. So we know that with 5G, application will first expanded from the mobile internet to IoT and implementing intensive integration with vertical industries. But actually, we are still doing some exercise and investigating on that. So currently, if we start with 6G as the next generation, we expect 6G to further expand and deepen the application scope. So maybe it is the right time for us to first identify the user and application trends, and especially the application scenarios for 6G, make a foundation for its success in maybe 10 years' time. So when we do the investigation on 6G, it is also, we need to keep in mind that the successful development, commercialization of 5G will be a solid foundation for 6G. So I think there's 2 things going on in parallel. Yeah.
Well, thanks very much. Thanks very much. Luciano, you had a very interesting presentation from Brazil perspective. And you mentioned that coverage or digital inclusion as one of the drivers. First of all, why do you think 6G will address the coverage to start with, and 5G cannot do? And the second one is, how do you make sure that is included as part of ITU or the standardization, that the focus on coverage doesn't get forgotten after a while? Because every generation we talk about coverage and cost efficiency, and then after a while we go to higher data rates.
Yeah, that's good points. Right? Well, 5G, of course, it's walk a little bit towards improving coverage. I think one good step towards the direction was the possibility to open the integration with other networks, mainly with the satellite networks. 5G has this Node-to-GPP interface gateway that we can now have offloading other technologies, which is a good step. The problem with coverage is basically the reason behind we create the physical layer. So if you look to 5G, it was very conservative in terms of technologies, right? So you had a lot of options in terms of physical layer that was dropped, and standard FDM was used at the end. And instead of opening the opportunity to have some configurations towards large coverage, it just moved towards small coverage. So enlarging the subcarriers, reducing the total frame, reducing the CP protection, the cyclic prefix protection, and allowing for a less challenging environment in terms of distance. So you cannot really deal with large delay profile and things like that. And they are more sensitive to mobility as well. So if you take the same technology and move it towards another direction, so shrink the bandwidth of the subcarriers, enlarge the frame, using large SCP would be more friendly towards the large coverage. So actually, we did that here in Brazil. We took the 3GPP standard and tailored a little bit the parameters towards what you needed in remote areas. And you are able to achieve 100 megabits per second, 50 kilometers away from the base station, using 6 + 6 watts in a MIMO system. So you can see that the technology actually can do it. You can provide long-range coverage in remote areas, but the motivation behind is always looking for increasing capacity, downloading fast, and those are the main points, because usually we only see the needs of some verticals and not the other verticals. So what 6G is doing now, it's opening for the opportunity to bring new requirements and show that, hey, there are other verticals here that have demands for high throughput. So every business does not need to only connect to one sensor in a call. They actually need to have multispectral cameras, gathering images in real time and provide that to AI on the cloud to detect, for example, the presence of plagues in huge plantations. So this kind of application you need to support now, and the opening for 6G is allowing us to bring those points into the matter. And I think the difference is now is something that's happening now here with the one6G association that can gather those demands, that can gather the technical contributions and provide a package that can be discussed in the standardization bodies.
Yeah. No, thanks very much for that. I think, Luciana, you mentioned something in your presentation that for the security, you would like to do behavior analysis. That is from the privacy point of view. What is the Brazil's position on that?
That's a very challenging question, right? So, as you know, public safety in Brazil, it's a huge challenge. And of course, there is a huge concern about privacy in public areas by monitoring behaviors and try to identify who are key or dangerous peoples and who are not, and how you can rely on AI to classify that. So there is no official position right now here in Brazil. What you have is the willing to study more about the subject, and if that can also be one tool to help authorities to prevent crimes activities in public areas. That's a very challenging question. I don't have a proper answer now. The concerns exist, you are aware of them, but I also believe that if you can more or less weight a little bit the inputs from the AI in terms of protection of people and also how the authority is going to use that information by not relying 100% on the outcome of the algorithm, I think it can be a tool that can help us to have a better life in a society.
Okay, no, thanks very much. Can I ask a question about the coverage? I think everybody talked about coverage and energy efficiency. I think that was common between all the presentation. But we know the law of physics says if you go higher frequency for the same amount of power, the coverage will shrink, will get smaller. So I think Takehiro-san presented a very good idea, use cases for sort of like 100 gigahertz, which is sub-terahertz for indoor coverage. But for the wide area cellular networks, what do you think would be the frequency bands it should be as extension of 5G or 6G to provide that balance between coverage and cost and power efficiency? Takehiro-san, you start.
Okay. Oh, thank you for your question. Yes. Yes, many people have a strong interest in the terahertz level for the 6G, but of course, we will use the existing spectrum band even for the 6G era. And we will use the both newly allocated the spectrum band like a terahertz level and existing band both, even for the 2030s. And hopefully, I really hope that excellent technologies that can be applicable even for the existing band, low band, mid band, even for the millimeter wave, can be identified and included in this future 3GPP specifications so that we can improve the system performance even for the existing low, mid, millimeter wave spectrum band, so that we can improve the capacity performance for full system perspective, yes. So it is important to study, research, not only for the terahertz level, but also the further improvement of the performance for the existing spectrum band, so that we will use all spectrum band in the 6G era. Yeah.
So you think that we should identify pioneer bands for 2030 plus as well?
Yeah, of course. In the future, of course, we will continuously use those kind of band. Yes, yeah. Sure. Yeah.
Okay, so thanks very much. David, you from NGMN, you are the voice of the operators, and cost, energy efficiency, coverage, capacity, everything is your everyday issue, and etc. What is your view on the frequency bands?
So thank you, Rahim. I don't think NGMN have got as far as saying, you know, what their view will be on spectrum bands, but I'm happy to chip in with some views and observations of myself. And I think, you know, as Takahiro-san has mentioned, and you very correctly have pointed out in your question, there's laws of physics that come into play. And for wide area mobile coverage, the laws of physics mean that the lower and mid-band frequencies will be the ones that will dominate in future years for wide area connectivity. We, as an operator, Vodafone and other operators, use the higher frequency bands or millimeter wave bands in more urban areas or campus networks or industrial applications. And this is one of the key things, I think, as an industry, we have to really work out and be clear when we talk about some of the very high frequency bands, whether it's terahertz or hundreds of gigahertz bands, what the applicability for some of those spectrum bands will be. That's one of the things I tried to touch on at the end of my presentation. When we look at use cases and when we look at technologies, we need to be quite clear in terms of how we articulate what these opportunities are and where they are opportunities. Because clearly very high frequency bands and the hundreds of gigahertz or terahertz frequency bands, they're not going to be applicable for wide area connectivity. And the other observation is spectrum is a finite resource. You know, we've been gifted with allocations in previous years and previous WRC cycles, but certainly in the low and mid-band allocations, there's less frequency available for the IMT, the mobile type allocations that we've had the fortunate access to in the past. So, you know, the trend I see is that there's much more discussion about sharing of spectrum, and that can be sharing either geographically or in time or in space in some form. And I think going forwards, we'll have to adapt our business models to use spectrum in a different way for these new spectrum allocations. They're not going to be national licensed allocations, or less likely to be, I think. It's more likely, I think, that we will need to find ways in which we share newer allocations in a sort of coordinated way with other users. And that's not to say that the primary license allocations that we have today will disappear. They're absolutely critical and essential to deliver the quality of service and managing the connectivity challenges. So these new shared bands hopefully will complement some 6G services in the future.
Yeah, thanks very much, David. That's very comprehensive answer. Can I ask Zhu as well? In China, do you have any idea about the frequency band or bands for 2030?
Not specific band, but we have a general consensus maybe within the anti-2030 promotion group, which is we think in the future, even in 6G, the efficient use of high, medium, and low frequency bands, the full bands are all very important to fulfill the 6G spectrum needs, because we think the 6G and the sub-6G bands are still quite a strategic resources for 6G, and those spectral efficiency can be maybe further improved with resource refarming, aggregation, and sharing. And sub-6G, 6 gigahertz band can provide the 6G with a basic continuous terrestrial coverage, achieving a faster and cost-effective deployment. So we should not abandon them. So this is quite a similar view with Nakamura-san and the previous speakers, I think, yeah. And at the same time, we'll continue to explore some higher frequency bands, because higher frequency bands can meet the requirements of ultra high speeds and capacity. And yeah, so that's the basic position for anti-2020 promotion group. Thank you.
Okay. What is ITU view on the frequency bands, or is too early to discuss?
No, for sure, this is a little bit early to discuss, because as I explained, we will have the identification of possible frequency spectrum, if there should be new spectrum at a later stage as part of one of the World Radio conferences. And beside of that, I agree fully and can just confirm, we will expect that the right mixture between high band and low band spectrum is key for the usage of 6G. In addition, of course, to exploiting some new frequency bands, which might be beyond the spectrum we are currently thinking about, so going beyond the 100 gigahertz. But as been said correctly, this is not, let's say, applicable for in particular covering rural areas like we have in a lot of the American countries or the African countries. So there we will need to use completely different spectrum bands. But as we all said, this will be a kind of how to say, use the right spectrum for the right application in the right location. I like to state that.
Yeah, yeah. So it's going to be a range of frequency bands.
Yes.
Yeah.
I just have figured out there are some question by the delegates as well, and I'm sure, Rahim, you have seen them. So
yes, I was going to come to that one. I see 2 questions from Alan Morad that I was going to come to that one.
Okay.
Yeah, I think there was one in your presentation. It was David and Bernard Brownie. They emphasized the EMF study and exposure. Could you elaborate on that? Is it going to be you support EMF exposure to be from the very beginning on the part of the study for 2030 plus?
So
Bernard first, because sorry.
I can say a few words on that. Thanks a lot, Rahim, for the question. First of all, you have to realize that in the Commission now it's getting a little bit quieter, but over the last couple of months or even the last 2 years, we have received an amazing amount of letters from all sorts of institutions or set of citizens or a set of professors asking us stop 5G, and we still have a lot of campaigns these days from some political parties which are trying to kind of restrict the deployment of 5G on the basis of radiations and on the basis of the fact that radiation are potentially harmful to health, which is the alleged position of the people who are presenting this type of opinions. And this is becoming a very sensitive issue. I mean, you may have heard that in Switzerland at some stage they stopped the deployment of their network precisely because of that type of concern. And we believe that there is a potential approach which is it's not the full response because of course there is a lot of emotion in this type of discussion. But we now see that the community and the researchers are looking into let's say, technological approaches which can potentially help to better control the radiation level. We have already it with 5G, with the idea that you can have much more directive beams, and with the fact that you really concentrate the energy where it's needed, and you don't radiate all over the place in places where that is not necessarily needed. So you you already, with this type of directivity mechanism, reduce the exposure. There are other mechanisms in 5G that could be claimed as reducing the exposure, which is the kind of sleep modes which have been introduced to reduce the energy consumption in such a way that at some stage when the traffic is low or there is not too much activity, the radiation level of let's say the emission level of the base station becomes lower, or if not stopped. But now we see with this technology, I don't know if this has been discussed already before, but we see a route of research which for us looks very interesting, very promising, which is this business of reflective intelligent surfaces, where again it's about really bringing the energy where it is needed and having a much better control of the channel. So it's not anymore reacting on the channel performances, but it's really shaping the channel in such a way that it really corresponds to what you want to transmit and what you want to serve in terms of applications. But this type of notions, this type of technology potentially could be used as a way to also have a much better control of the radiations. I know also that already today there are some potential definition of interfaces between operators. I think it's a work which is driven by GSMA, but this potentially hitting limits of business sensitive type of information. But of course, if operators would have a much better way to collaborate among themselves, it will help also to have a kind of wider visibility of the overall cartography of emissions in such a way that the best environment can be designed for this radiation. But again, technology will only be part of the solution, and it's an interesting dimension. It's probably a necessary condition, and that's not necessarily a sufficient condition, as they say in mathematics.
Yeah. David, you want to?
I don't think I've very much to add there. Thank you, Mr. Barani. I think you've covered just about everything very well. The only other maybe comment I throw in there, so far this discussion has been mostly about mobile technology. I mean, the other way that many people communicate, as I am right now, is using my Wi-Fi access point in the house. And maybe as an industry, we also need to consider what's the lowest energy, both by EMF and sustainability, that we provide wireless connections. It might indeed be it might be a hybrid converged network between local hotspots, Wi-Fi, and mobile networks. And at some point, we are constrained with EMF. We can't exceed various limits for very good reasons, and we might have to look at different ways in which we can deliver services with different connectivity solutions. I think Mr. Barani covered most of the research themes.
I think they're both very, very comprehensive answers, and I'm really pleased to see that it's part of the European Commission research agenda. I think that's. I'm not saying that there is a risk, but I think it's worth studying. And as part of the research and innovation activity. Takeru-san, what is Japan's view? Any activity going on the EMF exposure and reduction or whatever?
EMF. EMF. Sorry. What the EMF? Sorry, I don't know that.
Electromagnetic exposure.
Okay, we are calling it EMC. Okay.
Oh, okay. All right. Sorry about that.
Yes, of course. That's a very important topic, and but actually, so far that was not so identified as a very, very serious problem. But some people had a concern about 5G spectrum band. That actually, I received some letters on that kind of concerns. But in general, that was not so serious problem. But that is maybe thanks to the very careful research on the impact to the human body and the impact to the some devices from the millimeter wave or mobile communication, radio. And actually, my company also studying and developing the nice system to investigate the impact to the devices and the human body. Yeah, thanks to those kind of the activities, including my company and the other organizations, maybe we can set the proper regulations of the transmit power or something to keep to use the radio safe, yes, even for the existing spectrum band and also a newly allocated millimeter wave. Yeah, that's the Japanese.
No, thanks very much. Can I ask about the frequency bands? Then I'll move on to another aspect. We casually use the term terahertz. Do we mean sub-terahertz? Because terahertz actually starts from 1,000 gigahertz. What do we mean? What frequency band we mean when we say terahertz? Zhu, do you want to say that? It was a part of your presentation.
Yes, thank you, Professor Rahim. Yes, actually, we established a task group to do some research on the terahertz band, and in our presentation, I think we identified the sub-terahertz band, means some frequency maybe from around 1,000 gigahertz band to some band higher.
Oh, you mean 100? What do you mean 100 gigahertz?
Yes, 100 gigahertz band, and some and then to some frequency band which is higher. But we treated them, also treat the sub-terahertz band altogether, because maybe some band around there they have similar propagation characteristics.
Yeah.
And yes, I think this is a quite important topic and a research direction for the future investigation. And actually in the early stage in September, and Anti-2030 Promotion Group has published a report on this band, but this is still at a very initial stage. And we think to achieve the real commercial success in the terahertz band, we still have a long way to go. Yeah.
Yeah. I don't want to pick on the same people, but who wants to answer that? Is it, to add anything to what you said? Okay, David?
Yeah, I was just going to say, I mean, I think as an industry, we tend to use different names for different frequency bands quite regularly. And you're quite right that a terahertz should be 1,000 gigahertz, but we've used the phrase loosely. My view is probably anything which is above the allocations that were identified for IMT 2020. So they went up to what, 60 gigahertz. So really anything going beyond that in the IMT 2030 period will be what will become associated with terahertz. So it might be anything more than, say, 80 to 100 gigahertz. I think that phrase gets used quite loosely now.
Yeah. Do you think that we have enough knowledge and understanding of propagation of the sub-terahertz, say 80, 90, say to maximum 300 gigahertz? Do we understand how these things propagate? Who wants to go? Takehiro. Yeah, sorry. It's becoming very randomly. I'm picking people. So
yeah. If I can have enough time to provide my presentation today, I wanted to show some kind of the measurement result on the propagation results. Actually, we conducted some propagation measurements on using the 100 gigahertz, and line of sight situations. The results show that almost aligned with the channel modeling that was developed for the 5G. Yes. So of course, the propagation loss will be higher higher and higher in the sub-terahertz 100 gigahertz level, but aligned with the theory and the channel model. Yes, already we developed. But on the other hand, non-line of sight situation, the loss is higher than we expected based on the channel model developed in order 5G. We think that that is reasons why scattering loss will be higher. Yes, the very short wavelengths cause the much higher scattering loss, we guess. So that's the reasons why the non-line of sight situation propagation loss is higher than we expected. Yes. So we will conduct more trials or everywhere, many places, using the much higher spectrum band, like 300 gigahertz. But yeah, maybe we see that such kind of trend of the propagation. Yeah.
Yeah, I mean, that would be useful to see the use cases for terahertz. I mean, Kai, in Germany, do you have activities on terahertz measurement?
Yes, we have. As far as I'm concerned, it's, let's say, until the frequency of 300 gigahertz, and let's say there are a lot of activities, let's say, to come up with some channel models, also, let's say, for standardization, that later on, let's say, realistic, let's say, scenarios also are provided for the use cases, which have to be still defined. But there is some research and there will be some measurements made, definitely.
Okay, no, that's good.
Maybe I can.
Sorry,
yeah, Uwe, you go first.
Oh,
no,
yeah. I will give the chance to Uwe because I was going to mention that actually in ITUR there's a developing report on the bands above 100 gigahertz.
Yeah, this is.
So maybe this is what you want to mention.
Yeah, there are two aspects I wanted to mention. Indeed, I mean, as I mentioned earlier, ITU is contribution driven, and we have received to this particular report, what is mentioned by Alice so far, already contributions from the industry, and the expected finalization of this, let's say, above 100 gigahertz report is currently foreseen for end of next year. And we are expecting that for the next 3 meetings, there will be a lot of information provided. And I have had a look at the agenda yesterday evening, and I see after the lunch break, we will have also a demo from Professor Dr. Körner from the TU Braunschweig, and I know that his institute is very much detailed researching this terahertz spectrum. So I think we all will hear more about this later today.
Yeah, well, that's good. So we need to have a better understanding of the way that these terahertz, I know in Japan, there's activity in the Como is already started. And to meet your end of next year, you said for that for requirement for inputs, I think that probably need to prioritize that activity within our national and European sort of research to come up with some models, some better understanding of the terahertz frequency bands. Bernard, would you agree with that from the Commission point of view?
I cannot agree more. You know that we have already terahertz type of, or sub-terahertz, because it starts at about 130 gigahertz up to 300 gigahertz, the type of activities we are having in our research program at this moment in time. So we have a so-called terahertz cluster, which is looking into the, especially specifically to what you said, the propagation models and what Nakamura-san mentioned. I mean, the non-line of sight type of propagation properties. There is, in our project, there is a lot of focus though on the technological feasibility, because this is really stretching the envelope of the microelectronics capabilities of, let's say, chipsets. So at this moment in time, there is a lot of reflection running in industry. What is the best technology to implement this type of transceivers? Is it indium? There is a lot of promotion for indium phosphide, but there are some, let's say, industries or people who do not necessarily have the same ideas. So the way you are going to implement the technology to minimize the losses, to minimize the implementation losses in the receiver, to optimize the power amplifiers, and to also optimize the stability of the oscillators is something which is attracting a lot of interest in research domain. So we see this also as an important element to to drive the readiness of an industrial supply side if we have to go into this type of frequency bands at some stage.
Yeah. Okay. No, thanks very much. Let's look at the other aspects. I think all of us, I can say this one, we are from telecom background. And we talked about vertical industries. Do you think, well, I have to say that, what do you think about how do we incorporate the requirements of vertical industries into research, innovation, as well as standardization? Is that the lesson, one of the important lessons learned from 5G? I'm going to start with the national programs. For example, Kai, can you say what is your strategy?
Yes, I think it's very important. Let's say what we also learned from the, let's say, German 5G program regarding, let's say, industrial communications, to have them right at the beginning, because let's say in some cases they also talk a different language regarding, let's say, also latency, just as a simple example. And I think that's why it's very important to have them here on the boat.
No, okay, I agree. It is important. Do you have a mechanism to include them in your national program?
The mechanism is that they join these, let's say, projects as a partner that they can discuss. But also, let's say we have this 6G platform where there's a discussion possibility on certain topics as well, and especially, let's say, here the needs of verticals, that they also can adopt at an early stage maybe the technologies that can be expected.
Yeah. Okay. Uwe, I2UR, what do you do to incorporate the requirements of vertical industry?
That's very, very easy. We have, for the previous cycle for IMD 2020, asked the industry to provide their views and information by sending liaison statements to external organizations. We have received some input, but I think this was a little bit before this vertical jumped on the, how to say, 5G train. And now, as I have shown in my presentation, in particular, we have sent a liaison statement to more than 50 organizations, where I think a majority, a part of, is also engaged by the vertical industry to provide their requirements and demands for the next generation of mobile communication. And I'm quite confident we have still 3 meetings to gather their input, and we will receive the input, we will incorporate it, and then we will drive forward the specification and standards along this line, no doubt about.
Okay, let me ask you, have you, or probably you haven't analyzed the inputs. If you have, did you receive something that you didn't expect? Or is it different from the telecom sector?
Well, so if there would be information, I think it would be not appropriate to disclose them right now, because the report which stands behind is not yet finished. On the other hand, we have just started the liaison statement, sent the liaison out on June this year. We have received some initial input, that's correct, 2 or 3 inputs, providing some views for now for the October meeting, was actually just finished 2.5 weeks ago. And as I said, we have 2 more meetings to await the input by the verticals. And I'm aware of, and also I spoke to a lot of people within the one6G project. They are aware of this fact and they will contribute. So we need to wait a little bit.
Okay, okay. Takira-san, how do you make sure that you incorporate the industry, other industries' interest in your national program?
Yep, that's a very, very important topic. And yeah, actually, even from the 5G discussions, we tried to invite the vertical industry people. Yes, some industry people joined and provided their opinions, but I think that that is not so sufficient. And we need to invite more opinions from the other industries, and the more close communication between the industries and our industries, so that we can identify the real requirement from the industry, and we can facilitate the creation of the new business for the future. In order to do that, I really think that we should not wait for the joining from the other industry, vertical industry people. We should enter the other industries to provide our views on the 6G, and also try to get the information, opinions from other industries. So maybe some kind of the marketing strategy will be needed to have a more close communication between the industries. That's my thinking. Yeah.
Okay. I'm not going to ask Bernard, because I know European Commission programs is always emphasize inclusion of other industry, and there are so many ongoing projects that includes different sectors. So David, NGMN, all your members are telecom people.
Yeah.
So what you're going to do, is there any mechanism to incorporate some other people?
Yeah, so there are mechanisms, Raymond. We do have formal outreach procedures where we actually reach out to all the different industry sectors that we can identify as an organization. But as Takahiro-san mentions, my feeling is that we haven't been overwhelmed with responses. And I think partly that is because 5G in itself is still a very immature, relatively new technology. Most verticals are still getting their heads around what does 5G NR, new radio deliver that 4G didn't. And to be in truth, many of the enterprise and vertical needs are well served by good quality 4G LTE networks. There's only a subset that really requires super low latency or super high data rates. And quite often they have quite individual requirements. So those requirements might be to do with resilience or privacy or uplink data speeds. So there's a subset where some particular requirements are different, but actually for most people, they're still trying to get their head around 5G. So when we approach them and say, well, guys, do you know what? How about 6G? It's just, I think, a little bit too early for many of these organizations to really come up with a clear direction at this stage. And that's one of the challenges I think we face.
I think it's probably the take-up of the 5G by other industry is the highest in the world in China. So I've seen some statistics. So I'm not gonna, unless Zhu, you want to say something very briefly?
Yeah, maybe very briefly. I think I have to say that maybe to promote the telecommunications in other industry is not that it's not an easy task. I must admit that. And China actually has promote actively and try very hard to promote this 5G use in vertical industries, and also the MIIT hold a contest called the Blue Cup contest to promote the application of 5G in various industries, such as the healthcare and social governance, etc. So I think this contest has greatly promoted some activities in various fields, and it comes to an end. Maybe it's in the coming next week or the week after next week, there will be a contest result of this year. So we try our best to think of all kinds of activities to promote this mobile communications into other industries applications.
No, thanks. And Luciana, you said that you're working with agribusiness. Did you come up with the requirements that with you as a telecom expert you were not aware of?
The Brazil 6G project is actually driven by other verticals, not from the telecommunication itself. So basically what you do, you have this work group responsible for the requirements and also for the vision for the 6G in Brazil. and they go to the verticals and stakeholders and ask them what you're trying to do that you're not able to do with the current technology. What's holding you back? So you try to understand the problem and put that in terms of requirements, and that is feeding the telecommunication engineers in terms of how can you use technology to provide solutions for these specific problems. So we have done that with agribusiness. We understood why we cannot use 4G or even the current form of 5G to solve the problems that they are having. And then we are trying to build a new proposal for that. And with this idea, you are developing this proof of concept, these demonstrations, and you try to deploy that in the field and showing to those stakeholders that technology can be tailored for their case. So that's what the approach that you're using in order to increase and improve the contribution of all the verticals in 6G.
Okay, no, thanks very much. I think, Bernard, I'll come back to you. I said I'm going to skip that one because of the time. But what else is Commission is doing to make sure that vertical industry get involved in the EC programs?
Well, I think we have learned our lessons from the 5G program. The 5G program we started in the early 2010, 2012, something like that, so 2013, at a very sequential type of organization. So we started from research and prototyping, testing, pilots, and then use cases and bringing the users to the end. Now we try to do the things a little bit differently using this model that maybe you know, which is the spiral model of the Jenny initiative in the US when they are talking about this new generation of internet. So we try to have in parallel two things. One path that goes into 6G next technologies, and one path that goes into large-scale trials and pilots in such a way that we have the users, you have the users, yes, from the onset into the initiative, because our starting point is that 6G can be a success if 5G is a success. So we need to leverage 5G capabilities to move into 6G. So the way to attract the verticals from the onset is to provide them with a large-scale test platform that they can use from the onset, still with 5G or 5G advanced type of capabilities. Using these 5G advanced capabilities, they will bring back some additional requirements towards 6G development, which will be inserted into the platform as we evolve in the kind of spiral model. So we have this type of double track in our program that will hopefully, we are confident about it, help us to have the vertical from the onset into the program, not at the very end of the program as we have done it before, which was not an optimal way of doing things.
Yeah. Well, thanks very much for that. Let me go to one of the questions. I think it was asked by Alan Morad from Interdigital. I think he asked a very good question. He says, how do you see 6G differentiating itself from what is being planned for 5G Advanced in 3GPP release 18/19? Can I start with Takiro-san? Is the question asked at 10 at
Rahim, you should answer the question, Rahim.
Huh? No, you should. I have an answer, but I want to know from industry and the national program. How does 6G in Japan is different from 5G Advanced with release 18 and 19 3GPP?
Okay, yeah, that's understudy, yeah, actually. And of course, we should identify the very excellent new technologies that are completely different from the 5G. But actually, even from the 4G, it is very tricky to identify the very big gain technologies and symbolic technologies for each generation. Yeah, even for the 5G, we are continuously using the OFDM-based access technique, MIMO-based technique, but we introduced a small new technologies in addition to the 4G legacy systems. We think that even for 6G, we guess that similar approach, the small improvement technologies which are the small gain, but integrate many of the small technologies, and then we can achieve the very big gain. Yes, and maybe a 6C will be that kind of approach. But still, I personally, I really want to have a very nice technologies which has a very big gain, and that can be some kind of a symbolic technology to define the 6C. But I know that it's a little bit tricky. Yeah.
It will come out. It will come out. Shu, from China, how does 6G it differs from release 1819?
I think it's early for us to identify whether 6G will be a totally revolution compared to 5G, because I think all the technology is developing now. But currently we have seen a quite important trend, a technology trend for the next 10 years, which is communication will be deeply integrated, maybe with sensing and also with computing and with control. So this is a quite important trend. And I know that actually in release 18, there are some people are already discussing the AI in the wireless, in the radio network, and also some sensing combined with communication, maybe just to start to talk. So I think maybe we do not need to differentiate intentionally which is 5G, which is 6G. But it is still in a developing pace, and we will see how it goes. But personally, I expect that maybe there is not a revolution, maybe more like an evolution of the technology. Yeah.
Can I ask you a question? Why can't we integrate sensing into 5G or 4G? Do we need to call it 6G? AI, computing, edge computing, all of this can be done with 5G.
Yeah, but maybe in different design principle. So I think I heard that there's some discussion in, for example, in 2030 promotion group, we have an emphasis on the native AI or native security. That means from the beginning of the design of the system, we should consider the other capability like AI or like sensing that may bring a different revolution on the architecture itself. So that may make a difference from what it is discussed on release 18 in 3GPP, because in the current 3GPP discussion, maybe that's based on the previous architecture of the network. Yeah.
Okay. Okay. I think we got about 5 minutes, and I've got so many questions, and there is. I try to not to ask my question, but ask from people. For example, Egon Schultz says, what is the role of visible light in 6G? First, Bernard, is it visible light part of the, or you don't specify it as part of the your program?
I will be very clear with you. For the moment, we don't specify it as a specific new radio, it's not a radio, but a new access type, new access methodology. We are not in favor, not against. We are just waiting for the proposals from the stakeholders to see what they think of it and how they think it could be integrated as one of the possible access methodologies.
Yeah. Uwe, is any of interest, is on the radar of I2R visible light?
No, as I said in my presentation, and even written, it is one of the technologies which has been included and will be discussed in the technology trends reports. But as just been said, we are waiting also for the input and the conclusion on this, and whether this is going to be at the very end a new radio communication technology still needs to be seen. I think it's too early on that.
Okay.
But just one thing, I have been looking while we were discussing and seeing this question just on visible lights, and I have just recognized there has been published a report on the 9th of November, so actually just last year, that there is around 5 billion of market revenue in addition to this visible light. So it cannot be so far out of the consideration. Just a new report has been published.
Not yesterday, you mean last year, 9th of November?
I think it was 9th of November yesterday. If I check the internet,
not
probably.
Last year. Okay, last year, yesterday. Takiro-san, is visible light part of the portfolio of your R&D activity in Japan?
Yeah, that's included, I think, but not a popular topic yet. But on the other hand, visible light or optical topic technologies are very important to develop the whole of the 6G system, we believe. And actually, my parents' company, NTT, announced their concept, so-called ION, Innovative Optical and Wireless Network. Yeah. So we think that in order to have a high performance of the end-to-end connections, we should study not only the radio part, but also the optical wired part also. So it is important to study on the optical visible light. Yes, also. Yeah, that's my thinking.
We got about 2 minutes. I've been asking my questions as well as people online question. Can we go around the table, maximum 30 seconds per person, to see what they would like to highlight that we didn't discuss? I'm going to start with Bernard Berani.
Thanks a lot. 2 things maybe to highlight on our side. First, the societal issues. I mean, the fact that we want very much this new technology to be pushed by technologies that can be really capable of bringing down the energy, bringing down the EMF. So these kind of things are for us very important. And then, because I could not attend the full panel, so I don't know if this was touched upon, but the idea of network disaggregation, softwareization of network, these concepts that you see emerging in Open RAN and vRAN are for us very important, and how this will drive the 6G envelope is something that we have to take a careful look on.
Yeah, no, thank you. I think David mentioned that one in his presentation. David, anything that you want to highlight for the audience before?
The thing that maybe we haven't touched on, or we have loosely, is the sort of evolution path of 5G. I mean, we've talked about the technologies, how they can be embedded in 5G going forward. And that transition, I think, also will be quite difficult to say when does something go from 5G to 6G. The only other comment I was going to say on that as well is that both in the radio interface for 5G new radio, it was actually designed with forward compatibility in mind. So there's the capabilities of introducing new components and new frame structures in 5G NR, which actually provide it with that future-proof type of approach. And of course, in the core network side, the transition to cloud-native softwareization and so forth also means that's got a very long future-proof type of evolution. So I think it's going to be very difficult to make that sort of clear distinction between 5G and 6G. I think we're just going to evolve over time, and 6G might just become this group of technologies, features, services that we deliver in 2030. And we shouldn't beat ourselves up trying to find out what that technology and differentiation is.
Yeah.
Thank you.
Yeah, I agree. Shu, 10 seconds, please.
Yes, maybe I think mobile communication will be further integrated with the emerging technologies. So this is becoming a very obvious trend, such as emerging with AI and big data and cloud computing and something like that. The in-depth convergence of the data operation, information and communication technology will be important for the innovation of the next generation network. Thank you.
Luciano,
one point to highlight is that the 6G should take consideration the demands of markets that are not traditional ones. So look to other markets, see what they need and how the technology can solve it. Yeah. And of course, for doing that, we need to look to a broad band of technologies. So open the network for other RAN technologies, not just the ones that standardized by 2GPP.
Okay, thank you, Erasan. Any last?
Yeah, short. Yes. Yeah. Wireless communication underwater. Yeah.
Underwater. Okay.
Underwater. That's very interesting.
To the point. Thanks very much, Uwe.
It sounds indeed very interesting, and this would also fit to my last. The work on 6G in any aspect should match the work against the 17 Sustainable Development Goals of the United Nations, as has already been touched also by Bernard.
Yeah, very good. Kai.
Yeah, everybody is talking about, let's say, software in 6G. I would like to emphasize that there's also lots of work to do in hardware, let's say from component to material level, and these offer many opportunities.
Thank you very much. As you can gather, there's lots of questions to be asked to clarify, but we will hope that in future 1/6G workshops and meetings, we can address other aspects. And thanks very much for participation with enthusiasm and a passion in this, and honestly, in the discussion. Thanks very much. Have a good day.